Okay. All right, as much as we want to talk about football and all that junk, we're not. We are focusing in on our chapter 3 because we want to do well. So here we go. Number 1, practice test 1. Consider this equation. Is it growth or decay? Growth. We know it's growth because this number right here is more than 1. What is the percent of growth? 2%. So you look at this number right here, the one with the X, and you say to yourself, is it bigger than 1 or less than 1? Then you say, how much bigger than 1 is it? Well, it's 2% bigger than 1. So the percent of growth is 2%. What is the initial value? 3. Done. Now we're supposed to write an exponential that contains these 2 points. Okay, now remember, an exponential is going to look like y equals a times b to the x. Just like this is an exponential. That's your a, that's your b. Okay? Now, what do? Uh-oh.
Use the points and like.
Use the points, that's right. And I always start with the one that's got a 0 in it. Always start with the 0 point. And so y is 2. And x is 0. And what do I know about b to the 0? It's 1. So this just says 2 equals a. So now I know in my equation that a is 2. We talked about this a lot. This number is always a. So you can actually just skip to that, or you can go through the steps that we just went through. Okay? Tate, you writing this down, sweetie? Good. Okay. Now I'm going to use the other point. So 18 equals 2b to the second. Remember, I put y in there and x in there. How do I solve that? What's the first thing I need to do to get my b? I need to divide by 2. So 9 equals b squared.
3.
And then b is going to be 3. So my answer is y equals 2 times 3 to the x. Do not ever combine the 2 and the 3. They never combine. They stay separate. It's a times b to the x. 2 times 3 to the x. Now we have a whole set of problems that are exactly like the quiz questions you just took. Okay, so let's see. 8 to the negative second. What's that equal? 8 to the negative second. 1 over 8 squared. And 1 over 64. That was easy. All right, what about this one? 1/4 to the negative third. That's going to flip because of the negative, right? And become just 4 to the third, which is 64. 4 times 4 times 4. Remember, negative exponents flip you. Negative exponents flip you. How about C? I'm not even going to write it down. What's the answer to C? 5. Because anytime an ln and an e are touching, they cancel. So C is just 5. Now D, you might want to set that equal to x. You might want to say, okay, what does this equal? Log base 4 of 16 equals what? because when you put an equals in there, then you can loop-de-loo it. And it might be a little easier for you to see. 4 to the x equals 16. So what does it equal? What is that x value? 2. 4 to the second is 16. You can also do that problem. This is fine. This is fine. You can also do that problem by saying log base 4 of 4 squared, because 16 is 4 squared. Those will cancel, because anytime those match, it cancels, and the answer is 2. So whichever way makes the most sense to you, do it. 2 is the answer. Here's another exponent one. 27 to the negative 2/3. What's step 1?
1/1.
Yep, negative makes it 1/27 to the 2/3. What does a fractional exponent mean? A radical. So we have 1/a radical. 27's underneath it. It's cube root squared. What's the cube root of 27? 3. So we have 1/3 squared. So our answer is 1/9. F is another big exponent problem. So what do you want to do first with this one? You've got some choices. Who has a thought on that? What would you like to do first?
Multiply everything by 2.
Take everything to the second power? Like distribute that too? Now, you're squaring. So that means you're going to have a 4 and a 9, because you're squaring. But now you've got double exponents, and double exponents always mean multiply. So we're going to have x to the 6th and y to the negative 8, and x to the 8th and y squared. Remember, double exponents, power to power, always means multiply. Okay, so this would be a good first step, but we are not done. What do you notice about your x's?
The one on the bottom is bigger.
The one on the bottom's bigger, which means you're going to have extras on the bottom. And since you got 6 and 8, you're going to have 2 extras on the bottom, because the number on the bottom is bigger. Now wait a second, we have a problem here. That's got to come down. Remember, they flip. So a negative exponent on the top is going to go to the bottom. So you're going to bring these 8 down, but you already have 2 down there. So now we have 10 on the bottom, 10 y's on the bottom. G is another one of those ones I'm not even going to write down. What is the answer to letter G? 9. Look at that problem and remember the property. When the base of the exponent and the base of the logarithm are the same, the 2's are the same, then the answer is just the other number. No work, that's just it. H. This is another one. I'm going to just say equals x. I want to know, what does it equal? What does the log of 1,000 equal? Now I'd love to loop-de-loo this, but there's something missing. What's missing?
A 10.
The 10, the base, the base. But when we don't have a base and we just have an LOG, we know the base is 10. So 10 to some power is 1,000. What power do I take 10 to get 1,000?
100.
Now be careful. 10 times 100 is 1,000, but it wouldn't be 10 to the 100. Yeah, that would be a big number, wouldn't it? 10 times 10 times 10 times 10. How many 10s does it take to get 1,000?
Is it 3?
It's 3. Yeah, it's 3. 10 cubed is 1,000. Be careful. This does not mean multiply. It means power. 10 to the x. Okay, how about 2/3 to the negative third? Flip it and make it 3/2. Because negative exponents flip. And now we'll cube each piece. So 3 cubed is 27 and 2 cubed is 8. Zane, you writing this down, sweetheart? Come on. We want to do super well. The more we practice, the better we'll be. So 27/8. And then J is another one I'm not going to write down. What's e to the ln 5 power? 5. Because anytime in any problem you have an e and an ln physically touching each other with nothing in between, they're going to cancel. All right. That wasn't so bad.
I'm tired.
It's exhausting having to come to school, isn't it? Okay, A, let's look at it. Remember, as tired as you are and as boring as I am, you gotta pay attention, you gotta fight through it, because we gotta do well. Okay, so here we go. Look at this problem and tell me what to do. I've already done it twice today. So 3 to the second equals x minus 2. 9 equals x minus 2. And x equals 11. Everybody got that?
Yeah.
Pretty easy. Okay, tell me about this one. Hector, do you have an idea how we might start that problem? Exactly. So 2 to the x equals 8. Divide both sides by 3. Now, some of you don't need to show any more work, because some of you know what power you take 2 to get 8. So it's okay if you just write x equals 3. That's perfectly okay. But if you're not sure about that, or if the next problem is harder than that, remember you want to get a common base. So 2 to the x equals 2 to the third. So that's why x equals 3. But if you can just tell the answer, it's okay. That's all right. This one's a little bit trickier, but not the way we start. We are going to start the same way we've always started, and that is what? Divide by 3. Now, I know that's going to leave me a fraction over here, but that's life in the fast lane. We're grown-up kids now. We have to deal with it. What? Okay, we're going to loop-de-loo this problem, but there's no base. This problem is just like this one. It has a log equal to a number. And whenever you have a log equal to a number, you're going to loop-de-loo. So you got to remember that this is a base of e. ln means base e. There's only 2 bases you have to stick in. log, stick in a 10, ln, stick in an e. Now we can say e to the 1/3 equals x, and we're done. That's the answer. Remember, e's can stay in your answer. Well, they have to if you don't have a calculator. E to the 1/3 equals x. Okay, what do you think about the next one? I need a starting move. Divide by, not divide by 9, divide by 36. I want to get rid of my coefficient. So I'm going to divide both sides by 36. Now I've got 1/2 to the x minus 1 equals, now I'm going to reduce that. What's 9 over 36? 1/4. And that is a really nice number to have, because what do we know about 1/4? Isn't it 1/2 squared? Isn't 1/2 times 1/2 1/4? So now the bases match. They're both 1/2s. So I can say x minus 1 equals 2 and x equals 3. Some of these are a little trickier than others. This number's super simple. All right, what about this? This is a longer problem. What do you think? Make it 1 log. I heard somebody say make it 1 log. You can't have 2 on the same side. So these are going to be put together into 1. Okay? X plus 1 over x, Clara says. And why did she choose to divide? Because that's a minus. Now, tell me what I do when my problem looks like that. Loop-de-loop. Absolutely. So 3 to the second equals x plus 1 over x. 3 to the second equals x plus 1 over x. All right, so 9 equals x plus 1 over x. You guys know how to solve these equations. Don't freak out. Multiply both sides by x. So 9x equals x plus 1. Multiply both sides by x. Subtract the x. And divide. So what are we remembering on a problem like E? We cannot have more than 1 logarithm on the side. So if we have a problem that has more than 1 logarithm on a side of an equation, we have to put them together. So look at the next problem. Aren't we going to have to do the same thing?
Yeah.
Now, there's nothing wrong with this logarithm because there's only 1 on that side. So I'm not going to worry about him. These two have to go together.
3x minus 2 over x.
Yep. 3x minus 2 over x. Why are they going together as a divide?
Because subtraction.
Because that's a subtract. If that's a plus, they go together as a times.
So would it have been 4x? If it wasn't plus?
No, it would be 3x squared. They go together as a multiply. So you would multiply x times this.
So it would be 3x squared minus 2x.
Yep. But it's not. It's this. Now, this problem, I erased it already, but this looks different than the last problem. Because in the last problem, this over here was like a 2. And when a problem looks like that, logarithm equals a number, we loop-de-loop. but it doesn't look like that. This one has another logarithm over here. What do we do when we have a logarithm equal to a logarithm? We cancel them out. So 3x minus 2 over x equals x. So now I'll multiply both sides. So I have x squared equals 3x minus 2. Uh-oh, this is big and bad. What do I do now?
Got a square root.
No, I don't want to square root it.
Could you subtract the x squared to the other side of the factor?
Exactly. So Gabe says this is a quadratic equation. So it has to be set equal to 0. And then, if he wants the factor, great. If you want to use the quadratic formula, great. But you got to get it set equal to 0. And Gabe, I have issues, and always have since I was younger than you guys, with negative x squared. So I'm gonna put the 0 over here and move the 3x and the 2. But you can do it your way. It's just hard for me. You can do it either way. You gotta get a 0. Alright, so I moved all this stuff over here. Now, does that one happen to factor? Minus 2 minus 1. So I'm going to get two answers to the problem. I'm going to get x equal to 2 or x equal to 1. Right? And that's it. One more time, gang. I know that I'm not the most exciting person in the world. I'm not exciting at all. I know that. But this is how we got to do this. We just got to do it. So ln x equals -1. Or I guess if you don't want to do this, we'll just take the test next time. Right? I mean, the review's valuable. We need to do it. You need to participate.
A base E.
Yep.
And then you can use
And then we loop-de-loop. That's exactly right. This is a log equal to a number. Clara says I need to loop-de-loop, but I'm missing my base. So I'm going to remember ln means there's an E. So E to the -1st equals x. What do I do with a negative exponent?
Flip it.
1 over. So it's 1 over e to the 1st. 1 over e to the 1st. What about this one? Who knows what to do here? It's easy.
Make the 27 to an exponent.
Make what?
27 to an exponent.
Yes. So what? So 27 is going to be what? How am I going to rewrite 27? 3 to the 3rd. 27 is 3 to the 3rd. Perfect. What's 9? 3 squared. So the moral of the story is you want to get both of these numbers to be the same number. Kids, it's not like it's an 11 and a 13. It's a 27 and a 9. 3 cubed, 3 squared. Once you get them the same, then you can set the exponents equal. So 3x equals 2. Remember, back-to-back exponents mean multiply. So x equals 2/3. Last one on this page. Log base x of 9 equals 2. Loop-de-loop. It's a log equal to a number. So x to the 2nd equals 9. So x must be 3.
Oh, bathroom real quick?
Can you just hold on for a few more minutes?
Yeah.
Number 5. Write as a single logarithm. So those of you that were here this morning, we practiced about 1 million of these. We're going to make this log something. That's the goal. 1 logarithm. Not 2, 1. Who remembers or who knows?
M to the 4th.
Yeah, this becomes an exponent. So now we have log m to the 4th minus log n, okay?
And you put it in like a fraction.
What will it be?
M to the 4th minus n.
Over n, divided by n, yep, exactly. Why did she put it together as a division problem? Because it's a subtraction. And then 6 is exactly the opposite. So you're going to do the same exact thing backwards.
Would it be log 3x?
So it'd be 3 log x. Remember the exponent comes out in front.
Yep.
So it'd be 3 log x.
Minus 2 log y.
Minus 2 log y. Very, very good. That's exactly right. Exponents come out in front. And again, he chose to do a minus because this was a division. All right, now we need our calculator. The log base 7 of 19 equals x. Now, we've said a couple of times already today that when we have log equal to something, we're going to loop-de-loop. So 7 to the x equals 19. Now I'm going to log both sides. The exponent comes out in front. And I'm going to type into my calculator the log of 19 divided by the log of 7. Does anybody remember talking about the change of base formula? It said in a situation like this, it's always the log of this number divided by the log of that number. So you don't need to do this process. If you can remember the formula, it's always going to be log this divided by log this. The bottom number stays on the bottom, so it's log 19 over log 7. These are the steps you go through, but you don't need to do that if you can remember that formula. So we type it in, round to the nearest 1,000. So that will be 3 decimal places. So log 19 divided by log 7 is 1.513. And again, you know, if you had log base 8 of 10, you can go through those steps, or you can just say, okay, that's going to be the log of 10 divided by the log of 8. Always, always, always. All right, what's next? 5 times 8 to the x equals 12. Divide by 5. So 8 to the x equals, and you can either leave it 12/5, or that is a decimal. So if you'd rather say 2.4, that's fine. Doesn't matter. The fraction is fine. 12/5. Now, we had one like this on our quiz and we had one earlier. The difference was these two numbers could be made the same, like it was an 8 and a 27, or a 4 and an 8, or something like that. Not an 8 and a 27, a 9 and a 27, or a 4 and an 8, something like that. You can't do that here. So since your variable is an exponent, you're going to need logarithms. And that means the exponent comes out in front. So x log 8 equals log 2.4. And I'll divide the log of 2.4 by the log of 8. All right, did everybody follow all those steps? Step 1, divide by this number. Always, always, always divide by that number. You cannot get a common base, so we're going to have to take the logarithm of both sides, pull the exponent off, and then divide. So log 2.4, close parentheses, divided by log 8, 0.421. One more on this page, and then we'll have our word problems, and we'll be finished with the whole practice test. All right, so negative 2e to the 3.8x equals negative 12. Step 1, divide by negative 2. So e to the 3.8x equals 6. We are right back where we were over here. Only instead of logging both sides, we'll ln, because this problem has an e. And the beautiful thing is, that will cancel. So I have 3.8x equals ln 6. And then I'll just divide. So ln 6 divided by 3.8. Remember to close the parentheses. ln 6, close parentheses, divided by 3.8. I got 0.472. All right, and then we got 3 word problems. That's it. We're done. All right. Let's get as many of these done as we can. We'll finish the rest next time. How long will it take for an investment to grow into this if the bank pays this much interest compounded daily? All right. Compounded daily are the keywords. The formula we're going to use is our compounded interest formula. I'm going to give you the formulas, but you're going to need to know which one to use. So compound interest, here we go. How long will it take for an investment of 6543? So this is 6543 to grow into, what is that, $10,000? If the bank pays 0.01875 interest compounded daily. Now, compounded daily means N is what? How many days in a year? 365. Okay? This is going to be a mess. But here we go. We got a calculator, thank goodness. What's the first thing I'm going to do? I'm going to divide by this number right here. So 1,000 over 6,543. Oh, was that 2,000? Oh, 10,000. Yeah, 10,000. Thank you. 10,000 over 6,543 equals 1 plus 0.01875 divided by 365 raised to the 365 teeth. I just have a feeling that I'm not going to be able to do that. Yep. So I'm going to have to leave it like this. Okay, we're going to tough our way through this. Here we go. I need to solve for t. What am I going to need to do?
A log.
I need a log. I absolutely need a log. Now, I know this problem looks like an arithmetic mess, and it is, but you are trying to solve for an exponent, so you are going to need a logarithm. So I have the log of 10,000 over 6,543 equal to 365t times the log of that big ugly parentheses. I know it's a hassle writing all this down, it's just too bad. I do it. So all I did was put the log on both sides, and then that pulls the exponent out in front. Okay, is everybody to this point? Okay, now does everybody realize that in order to solve for t, to get t by itself, that's our goal, to get t by itself, we're going to have to divide over the 365 and the log of that big parentheses. Would everybody agree with that? Okay, let's get this typed in and then we'll be done. So here's how we're going to type this into our calculator. We're going to type, everybody knows how to do this part. We're going to have log 10,000 divided by 365, close the parentheses. Oh, not 365, oh my God. 10,000 divided by 6,543, close the parentheses. So log 10,000, make sure I have zeros, divided by 6,543, and then close your parentheses. Okay, now hit divided by, and then put a parentheses, because you're dividing by two things. So put it divided by parentheses 365 log 1 plus 0.01875 divided by 365, close parentheses, close parentheses. And your answer is 22.624 years. 22.624 years. If you type in exactly what I have written right here, nothing extra, nothing, I don't leave anything out, you'll get the right answer. All right. Bring that back. We got to finish it next time.